Need a hinge? There's a tool for that. Unlike in Trials HD where there were a bunch of different hinges with different purposes, in Evo we only have one physics joint, and by adjusting its properties you can make it work like any hinge in Trials HD and a whole lot more. The physics joint is found in the common category under the physics subheading. Once spawned in the game world, the joint appears as just an icon. The first thing you need when working with the physics joint is two objects to join together. For demonstration purposes, I've placed a couple flat ramp pieces, so let's open up our joint properties and see what's up. Before we get into the various properties, I'm going to connect our two ramp pieces so that we can see the visualizations that go along with properties as we change them. We'll start by scrolling down to select target 1. Clicking this will bring up a cursor we can use to select our first object. Then we'll do the same thing with select target 2. Now we have a few new visualizations. First we get two blue dotted lines coming out of our joint icon. These just give you a visual cue that lets you know what items the joint is connected to. The second is this red circle surrounding a small yellow icon. This yellow icon represents the pivot point, or where the actual joint is, and the red circle represents the joint's range of motion. By default, they will be placed at the center point between the two objects, with orientation based on the orientation of the two objects. If you back out of the properties menu, you can of course grab the pivot point to move it and rotate it to get it to the position you desire. The pivot point also has two pink dotted lines that are a visual representation of the connection it has to the target objects. We'll place our hinge and select the physics joint icon so we can get back to the properties menu. The first option is type. This determines how the joint will work. There are 6 options. Rotational hinges rotate on 1 to 3 axes and have a full 360-degree range of motion. Turning hinges rotate on one axis and have a limited range of motion, by default 90 degrees. Point to point is easiest to describe as a weak glue connection. It will resist movement in any direction, but still has a little give. The ball socket rotates on every axis but has limited range of motion, by default 45 degrees. The spring works similar to a spring in the real world. It can be pushed in basically any direction, but it will then push back in the opposite direction. Slider has no rotation, but moves 2 pieces apart on 1 to 3 axes. Next we have presets. These will change depending on what type of joint you are making, but generally, you will get 2 to 3 choices that manipulate range of motion, either by degrees, axes, or the strength of the joint. Properties basically determines how many custom options you have to work with. With simple, you are working with mostly preset settings, but depending on the hinge you may have a few options to play with. Scroll over to advanced and a few more options open up. With user defined, every parameter available for adjusting becomes available. In user defined mode, the joint will retain the presets it has based on what was set before it was made user defined. But at this point, the type is no longer important, as you can adjust the various parameters to make any type of joint you want. From here on out, I'll leave it in user defined mode so we can take a look at all the options. The enabled checkbox is an option we've seen before, but one thing to note with joints is that when it is not enabled, it's basically like it does not exist, so the two parts will simply fall apart as if the joint was not there. We've already looked at selecting targets, so next is linear settings. Most of the settings in this submenu adjust the limits of linear movement. In here we also have another submenu, linear motor. This basically adds force to the joint. For all you Trials HD editors who agonized over creating lifts and moving platforms, with the slider and linear motor, this is now a breeze. The next 6 values will adjust the range of linear movement the joint has on the 3 axes. For rotational joints, all these values will generally be 0. But for springs and sliders, you will need to allow some linear movement, so this is where you can set how much. Next we have linear softness. This determines how strong the connection the joint makes is. A value of 0 is strongest. The joint will resist separating, but at 100 the joint is weak or soft. It will easily be able to be pulled apart. Damping is next, and just like damping we've seen before in other tools, raising the value on this slider will slow the movement of the joint. Our final setting here is restitution. Just like object restitution, this determines how bouncy the joint is when it reaches its limits of motion. Set to 100, the object will bounce some, but set to 0, there will be no bounce. Next are angular settings. This menu has all the same settings as linear, but deals with angular motion instead. After that, we have spring settings. This menu has 3 options. Linear stiffness sets the linear strength of the spring. The higher the number, the more force it will take to push the spring in, and in return it applies more force when it bounces back. Lower the number and the spring will be easier to push in, but apply less force when it pushes back out. Next is angular stiffness. This is of course the same as linear stiffness, only for angular motion. And finally, check the enable checkbox to make your joint a spring. The disable collision checkbox comes in really handy. Check this and the 2 objects connected by the joint will not be able to collide with each other, but will still retain their normal collision properties with all other objects. For example, it will often be the case that 2 platforms joined by a hinge will not react properly because they are too close together. With collision disabled, this is not a problem. By unchecking the pivots combined checkbox, you can choose to move the joint's pivots independently. When making rotational hinges, you will generally want the pivots combined, but if for example you are making a spring, you can pull the pivots apart and it's like preloading the spring. The 2 pivots will immediately pull back together when physics are activated, creating a slingshot effect. Joint strength will obviously increase the strength of the joint. This will be more important when working with some types of joints more than others, and likewise when working with heavier objects connected to the joint. Keep in mind when adjusting joint strength that the more you increase it, the more likely it is to cause performance issues. Finally, just as when we discussed gluing, select pivot point is an easy way to select the pivot point if it's placed in an area that makes it hard to grab.